Good evening. Alright guys, we are continuing today on our discussion on the topic of probability, and we have talked about the differences between theoretical and experimental. You guys took a quiz today in class in the computer lab where you were able to see, kind of get some more practice with that. And so now we're just going to take that knowledge, that base that we have already of probability, and we're going to do a little extension. We're going to extend it a little further. The first thing I want to do is give you some more vocabulary. These are some things that you might see in the future. Hint, hint. Usually that means on a test. Okay. So the first thing I want you to write down is this. I could write that says fair. I'm gonna erase that and start over because I do not want anybody to be confused over what my writing is. Hey, it's a Monday. You have to give me a pass. Fair. A fair numbered cube. You're gonna see this term. A fair numbered cube is the same thing as a die, or dice, which is plural for die. Okay, it's a fair numbered cube. It means that it's has 6 sides, and all sides have a different number. Usually 1 through 6, right? So there's not going to be a 1 on there twice, or there's not going to be a 2 on there 3 times. It's fairly numbered. Okay, there's just one side. So if you see a fair numbered cube, just know that that's the same thing as a die. So it says roll a fair numbered cube, blah, 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 blah. What's the probability of rolling a 4 on a fair numbered cube? Well, that's 1 out of 6. Okay? So the next term we're going to look at tonight is complement. Complement. Okay. So when you see complement, your first thought is, oh, I like your shoes, or you look nice today. Those are compliments, right? Well, in math, a compliment, in speaking of probability, they have complements that they complete the whole, is what it is. But in probability, the complement of any event is the event that does not occur. Okay, so let me explain this. It's the leftover. That's what I call it. Or the event that did not occur. Emphasis on the not. Okay? So here's an example. What is the complement to months that have 31 days? Okay. What's the complement to months that have 31 days? So the first thing you have to do is you have to figure out how many months have 31 days. Then we can do that. We can, remember I taught you the little thing with the knuckles, right? So January, February, March, April, May, June, July, August, September, October, November, December, and every time you touch your knuckles, that's a 31-day month. So there's 1, 2, 3, 4, 5, 6, 7. Okay? 7 months. 7 months have 31 days. So that is the same as 7 out of 12, right? So the complement to this is like the other part that is not this event. So it just would be the leftovers. Well, how many months then do not have 31 days? Okay, so the complement is what's left over, 5 out of 12. That's your complement. So if you were to add these together, you can check complements by combining the two ratios, and they should equal 1. So, for instance, 7 out of 12 plus 5 out of 12 would be, they have the same denominator, so you can add your tops, 12 out of 12, which is the same as 1. Okay? So that's what a complement is, kind of the opposite, the leftovers when you, kind of the opposite that does not occur. Okay. The last thing we're going to be talking about tonight are those tree diagrams. So this is a tree diagram. I'll get out my green for trees. I figure that's a nice color for trees. A tree diagram is a simple way of representing a sequence of events. Okay, so it's a really easy way to map out visually probability. So here's an example. Flipping a coin and getting heads, and rolling a 4. Now, we already know how to compute this probability, right? We already know that because flipping a coin would be 1 out of 2, rolling a 4 would be 1 out of 6, and when it says and, that means you multiply. So you multiply these together. 1 out of 2 times 1 out of 6. So 1 out of 2 times 1 out of 6. Top times top. Bottom times bottom would be a 1 out of 12 chance, right? We know that. But when there's more, if you have a situation where it has a more complex problem, you can do what's called a tree diagram. Okay? So you start out with, I use a dot, okay? And you make 2 branches, hence the tree. If you were to roll, situation 1 is rolling a die, right? I mean flipping a coin. Flipping a coin. We're flipping a coin. The 2 outcomes you can have are heads or tails, right? And the probability of each, theoretically, is 1 over 2. Okay. Well, so we just did the first event, which is flipping a coin and getting on heads. Then we have to do the second event, which is rolling a 4. So let's say you flip a coin and it lands on heads. Well, then when you roll the dice, you could have a 1 in 6 chance that it will land on the 4. Right? 1 out of 6. But what's the complement to that? The complement would be that it would not land on a 4. And what's the probability of that complement? 5 out of 6. It's what's ever left over. Okay? So you could, these are your branches, I guess. I mean your leaves on the tree, if you will. So those are your 2 options if you rolled a heads, right? Let's look at it. Let's say you flip the coin and it's tails. So your 2 options for that would be the same. You roll a 4, and that's a 1 in 6 chance. Or you roll a not 4, anything but 4. And that is a 5 out of 6 chance. It's a complement. So a tree diagram really just helps you to map it out if you have some complex probability problems. And then you would know all of the options. You could have a heads in 4, a heads not 4. You could have a tails in 4, and a tails and not 4. So you go back to your answer. What's the probability of flipping a coin, landing on heads, and multiply on a 4? Okay, right? Well, rolling a 4. Heads and rolling a 4. Well, it would be this one right here. So this would be your answer. You would have a 1 out of 6 chance here times a 1 out of half. 1 out of half here. You would multiply these two to get your answer. 1 out of 6. That was landing on heads, and 1 out of 2 is landing on heads, and 1 out of 6 is not. Is rolling a 4. So then that's how you could again get your 1 out of 12. Okay? So that's a little bit about tree diagrams. There's basically a visual way for you to map out all the possible outcomes in a compound probability problem. Alright. Have a good night. See you tomorrow.